Let's see, what buttons do I mash to make that go away? There, I think I fixed the echo. Is that it? Yeah. Okay, cool. Super. I'm back after a week. It's been a week, all right, and that's a little ding that says it's time for the STEM steam engine. And my mind is a little elsewhere today. I've just taken some things off the printer. There's a war going on, all kinds of crazy stuff. So I've been a little distracted this week, and that may be common for other veterans too. I don't think I'm the only veteran who has experienced combat or deployments or has his family overseas or knows someone who might be involved. I fully appreciate it, and this is something that actually helps me take my mind off things. Doing some of this kind of like nerd stuff. This having projects to do, having things to keep me busy. If I were just sitting here, watching the news, doom scrolling, it's easy to spiral down into those crazy thoughts. So I'm making it a point to be here and to kind of be present and conscious and aware of the camera, both cameras. I've set up this elaborate station today, and there might be some weird shadows behind me and some glare and things this week, and this echo that I keep hearing. Wait a minute. Let's see if I can do that. Does that help with the echo? Let me make some noises here and see if that makes the echo go away. I think that does. Super duper. We'll check the other things, because I know that's an issue with Streamlabs. I get this. Each scene has its own little volume thing, so I'll pay attention to that when I flip screens. But I've got this crazy, my second phone is set up as a webcam with a ring light around it so you can get up and close and see some prints. If you caught any of this last week, let me just catch anybody up. So we have this design team for Battle of the Bots, which is a program that we run at the Lift and Shift Foundation, and one of our design team members helped me design a face shield, a face guard, for our robot, for our giant ranger robot tank, and we battle these, and it's the face guard looks cool. It looks cooler than what I did, so I dig it. But at the same time, it's a challenge to print. Excuse me, and I was aware that we would have problems this week, so I printed 2 different versions today, and it took 7 hours to print these. So I'm gonna share my 3D print program. The Slicer is what it's called. Cura is the name of the program. I'm gonna share that, and we're gonna dig through these 2 prints. I'm gonna get all up in their grills, literally, and share what worked, what didn't work, and how detailed it is to deal with things like support structures and adhesion type features that keep a print on the printer and working good. So I'm gonna stop talking. I'm gonna get rid of my screen here, and that's enough of a ramble. I just want to get right into it. I want to dig into this stuff here, and I don't know that tonight will be one of the nights that I drag over time. Usually I'm here for about 45 minutes, but we're going to get into it because I really want to see this, and I'm going to have to do some octopus type stuff to get around this ring light and this stand and everything to be able to grab and manipulate the parts. But let's dig right into it. Let's do this. Let me see if I can switch first. This is the Cura. This is my slicer. I use Cura because it's free, and like I said, when I design things here at the Lift and Shift Foundation, I like to use software that people can access without a cost. I don't want a barrier to entry for 3D printing or any of this other stuff. So this is Cura, and we can take a look and we can take a peek around, and I can drop models in here and change all kinds of settings, like the type of printer. I printed this on an Ender 3 today with generic PLA. We buy our PLA from a veteran-owned company, and they give us a tremendous discount because we're also a veteran-owned company. And I just would like to say thank you to 3D Fuel for supporting veterans and helping us with run programs and the things we do. So back to this view here. This is the Ender 3 model. The little work plane, the bottom. This is like the little print bed, the glass bed, and I used a standard quality. And then you can see a bunch of other settings here over here. If I click on the model, you can see where I can change, where it's positioned on the bed. I can make it bigger, which is a feature called scale. I can rotate it around. I can mirror it. I can flip it around. I can move it. I can change. If I had more than one model on here, I could change the individual features for an individual model. So I could actually do something like this, where I could multiply model, and then each model I could change settings on each model so that we could print one print but have different settings. That way we could test these. I did not do that today because I wanted to print. I wanted to see where the prints went, and I wanted to be able to change settings while prints were going on. I didn't want to spend all day editing prints. And here's something super convenient in Cura, which is called a support blocker. If you can see the word right there, it's probably really small on your screen, but that's something that I'm gonna talk about later, because that's a feature that would be really, really helpful in this specific print. So if we take a good look at this print, what we can see is there's a lot of stuff here that is not attached to this gray flat grid on the bottom. That is where the plastic has to stick to the bed. So I'm gonna go over here and show you this part. This is the view of what actually happens when this thing prints, and you can play and watch. This is where the plastic kind of like oozes out of the little nozzle right here. It's an extruder, so it extrudes the filament out of this nozzle at about 200 degrees. And you can see where it fills in right there, just filling in and filling in and filling in. It needs to, all of this plastic needs to be able to stick to this gray grid as it cools so that it can build the next layer, and each layer gets added to the layer underneath of it. So the awkward part for us is that if I pause this, because it's almost done anyway, and I come back over here, you can see there is so much of this just kind of like floating in the air. There's so much of this floating up here, and you can, if I come back to the prepare mode, you can kind of see underneath the blue part here, the light blue part, this turquoise looking color is the part that's attached to the bed. And you can see these red areas underneath are the parts that are that don't have anything underneath of them. It's just kind of floating there. That's a surface where there is no support under it. And that's something I use. I slipped in here with the standard quality, and I printed something called a support, which is right here. So I click the box for support, and then I get all these options for generating a support and everything else. And I printed one with support and one without support, so we can take a peek at this right now. And I'm going to come over to my screen. Let's close that up real quick. I'm going to come back over here. So let's take a zoom in close look. And this is the part where I'm going to have to dodge some of my camera here. Hey, hi, how you doing? Because I've got this like ring light on this stand with a clip for my other phone, and it's a bit of a challenge. So let's check this out. First, let's take a peek. I'm going to use this pointer today, and we're going to dig this out. This is actually, I use this for picking apart circuits and things. So it's cool to have a sharp implement and a pointer, but we're going to set this one aside. Actually, let's push this aside for now. You can see parts of it are coming off right here. If I get this in your face, you can see that's some of the plastic that's actually coming off, because this had really big issues. You can see part of the print here didn't even print. Nothing there. There's like nothing there. It's empty, and you can see all this extra part right here where the filament is just kind of hanging right there. So this part didn't print, and the same over here. This part didn't print, and it looks mangled, right? It looks mangled, and I'm going to go back into Cura and show this, and you can also see here where there was no support, so it's just kind of like not the shape that we expected to have, as some of the plastic is rough and hanging, and it didn't have anywhere to sit underneath of it, so it just kind of had to do whatever it's doing. And this right here is actually really fascinating, because this part didn't you can see here all of these underneath parts, they created their own way of kind of like building out until they crossed each other here. So it's super fascinating. But right in here, you might be able to, it's a little tiny blurry, I think, on my screen, but it's a part, but it's not really pretty. It's not pretty looking. It looks rough. You can see it there. So we had these sections here where like here between these two bars, right here, where the underneath looks really rough, right? And then we had these parts here on the sides that didn't even print. It could not connect the dots between these two ends here. And what you got was this kind of like rat's nest of filament, and it had an impact on the rest of this part. This is very, very flimsy right now. You can see I can bend it. I can almost snap it right off, and you can see the flex point is right here. Oh, if I back up, you can see the flex point is right here where this is bending, and I could literally break it off. I don't know that this would actually work too well for us as far as a face shield, because there's not much protection for the robot. And I mean, that's okay. This isn't, we're not on Junkyard Wars or anything, so we're not putting robots together that are massive amounts of force and torque. So it's possible this would work for a bit, but you can definitely see, if I come back over on this side, the flex happens right here. And now I'm gonna show you. This one has a support under it, and you can see all of the difference between these. And I'm gonna rotate both of these around right now, so you can see what's missing and what isn't missing, and ignore this big structure around it, because like I said, I'm gonna come back to that. But check it out, how much better the features look on this one as opposed to this one if you ignore this part, what the support structure looks like. So the support did an amazing job of providing the quality we need and the structural rigidity. I'm going to use a big fancy word, rigidity. And yeah, I'm still talking. You can still hear me. Okay, cool. So where this is flexing here, this one obviously isn't, because it's got all this structure around it, and we'll come back to some of that in just a second. But I did not do any post-processing on either of these. Sometimes when things come off a printer, you have to do a little work to make them completely a finished product. So this is two different prints, one with a support and one without a support. So now that you've taken kind of a peek at both of these, I'm gonna explain what happened and why this part is missing here and it's not here. So let's wander back over to Cura. And the cool part about Cura is that we can view this by layer and layer. So I need to slice it again. So if I do the slicing, you can see this took an hour, almost 2 hours to print with no support. And we can look at this layer by layer. So we can see that layer 1, we can see layer 4, and we can go up and up and up and up. And now we can see that there's this crazy grid. That's where the infill is, because we don't waste all of our plastic, all of our PLA on this material, so the inside of it is kind of like hollow with this mesh. And that goes up and up and up and up and up and up. And then the top cover basically goes on. Now you can see we're printing the actual little pieces that go on. So we're printing the actual, here if I grab one, you can see the layers starting to go up now. And you can see where layer on layer, if we go down to stop at the bottom right there, you can see where we're starting to print more and more and more of the actual grid, the face mask. And then something happens here, right about here. There we go. So you can see this red line right here. This red line is just kind of floating right there in the middle. This one right here. You can see it's floating. There's nothing under it. There's nothing above it. That is the very bottom of this round part. And it's just hanging there. There was nothing on it. And that is where the problem happened for us. We were trying to make this loop here without any structure underneath to support it. And I was in a hurry last week when we designed this, so I left it, and I knew it was going to be close, but I didn't realize the dip was that far down. I wasn't like I said, I was in a rush and not quite paying attention to that specific part of the detail. But that's where our problem occurred, and because of the flex everywhere else, we had all these other overhang issues out here, because this part was bending because it's just kind of like hanging there, so that there was no fancy looking support. Cool, super. So if I come back over here and we take a peek at this again, so let's check this out. So what is the benefit between having no support and support? Well, I will save this. Look at all of this material here. Look at all the extra material on this. This extra material, it is. I will come back and show. Well, I can't show you. It's not going to give you that great a deal. But you saw the print when I sliced this one. It took less than 2 hours. It took about 2 hours. This one takes about 4 hours to print. So already we're doubling the time, and we're also doubling, at least doubling the material. So check it out. So Cura does a pretty good job. Let's just look at this support structure here for a minute. And this is where I got the fancy ring light from. You can see it's not a real part of the mask. It's not meant to be part of it. You can see these little gaps right here and right here. And right down here at the bottom, you can see these little gaps, these little black spaces, because it's not completely touching the mask. It's very, very, very loosely attached. It's just there to give a structure. And each one of these little shells, it's literally like a shell, like you can see it. There's nothing in here. It's just a tower that keeps this from moving, so that this has something underneath of it to keep it upright. And that right here is what saved this outside part of the grid, the face mask. Having this support structure right here on it saved it. It allowed it to this dip here to print without anything floating. So if you print with a support structure, you get this added benefit of being able to really get down into details and dig through some of the tweaks and support. But the expense is the double in time, the double in material. If you're printing this for 4 hours, that's an extra 2 hours you can't print anything else. So from a business standpoint and from a production standpoint, printing the support structure costs more, not only for material but also for time. And that's something that people who run like a 3D print farms or something like that, they take that into consideration. The goal is to minimize not just the material you're using, but the print time as well. And because if this takes 4 hours, that means in one day, in one 24-hour day, I can only make 6 of them. But if this takes 2 hours, in a 24-hour day, I can make 12 of them, and that's more production. But there's this other problem. I have to process. I'm bumping cameras. I have to process. I'm going to give it the old air quotes. In fact, I'm going to get right back in your face. Air quotes process. This has to be processed more. Let's take a closer look. Okay, so processing means I need to peel away this part, and I left this on here like I mentioned earlier. I left this on here for a specific reason, because you can see it's very intricate where it chose to print parts of the structure, and from this angle it looks like I can break this apart. I can just pop something in here. And in fact, if when I do break this apart, I'm going to use this razor knife here, and I'm going to try to trim some of it, or break away some of it like this, without stabbing myself. And you can see that actually wasn't that bad. So I can kind of break it away a little bit. It's rigid all around, but each face would have to kind of like pry apart without breaking the rest of it. So let's see, I can go here. This already looks loose, and I can keep going up. You can kind of see I'm getting a little bit. Yeah, there we go. I'm getting around the top here. So the top is loose. Now it's the bottom that is fastened, and I can probably push this out right there. If I were to not bump the camera so much and use the other end of this to push it out, now you can see that I can pop this thing out. And I'm trying to be careful not to gouge myself up here. And of course, it's attached right here, is where it's attached. You can see that part right there. It's actually just attached right there. So I would have to break away the rest of these layers like an onion. It's this specific support structure is put together more like an onion, where I would have to peel each layer. And rather than struggle through this, I can snap parts off and on. But I'm going to leave it for now. I will end up peeling all of this off, and you can see it already. I've spent a couple minutes on this. It's going to take quite a few more minutes to basically carve all this off, and it'll be a cross of using my trusty X-Acto and this little pokey tool. I'm going to call it a pokey tool, to kind of like pressure parts off and on. And what might be easiest is this outside part right here that was so critical for us. But I'm going to leave this part alone, and I'm going to leave this part here, and I'm going to leave my tools visible for you. And we're going to come back to this view, because I'm going to spend the next 5 or 10 minutes sharing, a little bit about what happened here. So we saw that an hour and 50 minutes, almost 2 hours it took to print this. So let's come back over here. In fact, let's go back over here. Let's see the whole thing. That's what we saw printed right there on the right hand side with no support structure. It took, if you can read this little tiny box here in the corner, it took about 2 hours, and it used 11 grams of plastic. So if I go back to prepare and I turn on the generate support that I used, and now I slice it, all of a sudden We've gone from 11 grams to 22 grams. So we have doubled the amount of material, and the time it takes to print now is going to be 4 hours, just over 4 hours. So we've basically doubled everything to print this. And if you take a peek here, you will see all the structure in that light turquoise, that kind of like almost transparent turquoise. And that's what we didn't want to print, but it's held our mesh, our mask together, our face mask in one place. And here's where I'm going to come back. Did I mash the right buttons there? Hey, hi. Ooh, how you doing? So here's where I'm going to come back. Earlier, in the beginning, when I first opened my slicer, my Cura application, I clicked on this button that was called support blocker, and I said I'm going to come back to that, right? Now is when we should talk about it. So check it out. Ready? Oh, not there. There. Let's do this. So there's this thing called support blocker. So let's check out support blocker a little closer. So let's click on this guy. Oh, it's already doing it. So I have support blocker checked. So support blocker right here, now that box is blue, I can pick places where I don't want to support to print. So watch this. So for example, I can click on this part right here, and there's that square there. So let's slice this now, and let's see what happens. So you can see all the stuff inside that square will not get a support. So are you ready for this? So there you go. That part does not get a support. There is no support right in there underneath of this. And let's zoom out or scroll down layer by layer so you can see there is no support inside that box. Right there is missing support for that part. So we can literally use these little cubes to kind of like say, I want support over here, but not over here. And that's what we are looking at today. Like, how do we print this without the support everywhere? And the answer to that is this support blocker. I'm actually going to remove this block right here because that's a place we want. We want support right there on that little loop, right there on that loop. We want support there, so I don't want to block that, because that was one of our biggest problems. So let's come back and take a peek at this right here. So you can see where we had the biggest problems were on the outsides, where our little dip, didn't happen, and right here in the middle, where this looks all fuzzy. This looks all fuzzy, and it's just not very put together, right? So here in the middle and here on the outside, we really needed the support. And another point of matter, up here looks pretty close to the original with all the support. So I don't think we need all the support up here either. But on this eyebrow part, look at that. Look at that. Can you see? I don't even know if you can see that. I'm not even looking at the screen. Look at that. You can see that. That's the flex right there, and this is the flex right there. We need supports on those spots right there. So in the middle here and on the outside are the places we need to add that support. Everywhere else we can take a support away. And I even think up here at the very top we can take that support away too. So let's kind of translate that and transfer what we just looked at into our software. So let's take a peek back at Cura. What we can do now is we can grab our blocker and we can start with touching right there. There we go. 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 Excellent. Let's do the same thing on this side. Add all of this space right here. there's no support there. So that is excellent. That is very, very helpful. And remember I said we could probably even skip the top. So let's add support, or remove support from the very, very top. In fact, if we're going to remove support from the very, very top, we could probably go all the way up. Like that. Excellent. So let's check out what the print looks like now. We're going to slice it up. So we've taken an hour off the print time. We've taken, 5 grams off, so almost a quarter of the amount of material we've saved from the part with the support structure. And now let's take a peek at all of the layers and see what actually printed. Very cool. So we've got this support structure on the side, which will save us tremendously over here, right here. This big guy right here. We've got that, and we've got this one on this side, and then we've got a break. And what we see next is on the center, we've got this structure, but it does not cover the top. There's no support up here on the very top layer. We've kind of saved it for around the eye sockets, or the eye visor part of the actual center. And we could probably extend this a little bit further into the middle. But based on what we're looking at here, if we come back to this view, based on what I'm looking at here, we kind of want this one to have a bit more structure underneath of it. And if it's separate, that makes it easier to pop out. This one, man, I would be tempted here to actually get away from all of the only do inside these bars. Just the supports inside these bars at the top right here. That's where it looks like the problem happened. And same here, if you look bar to bar, that's where the problem happened here. So if we look at these vertical bars, we could kind of limit the structure to those. So let's come back to our Cura, our software here, and let's add the blocking right here, like that. Let's do it this way. Let's start on the outside. Oop, too far. A little bit back. Did we get all of that right there? Let's do this. Like that. Okay. So it looks like we've got all the underneath. Let's do it again over here. Nope, a little too far. We want to go to the bar, but we don't need to cover past the bar. Excellent. Excellent, Smithers. There'll be no releasing the hounds here. Okay. I feel good about that. Like, I feel really, really good about that. We've got all the support we need right between the vertical rail, the vertical bars. Down here, we've kind of come across the vertical bars a little more. But let's check out the slicing now. We're almost at 2.5 hours. We've got another 2 grams of material off of this. So we're creating a decent part. And the best part is, if we take a peek at this, what we're going to end up peeling off is getting smaller. We're gonna spend a lot less time now taking this turquoise, this like almost clear part away, and it's still on all the important parts. It's still between the vertical rails right here, and it's still very much supporting the eyebrow portion of the visor. So it looks pretty good right now. And of course we got the sides. That was exactly what we needed. In fact, we could probably block back here in the corner and cut off a little bit more even. So if I were to do this and kind of stick a block here, and a block here, we would cut off a little bit more. We could start really tweaking this a lot now. And technically, what we needed here from the loop was just the bottom. We needed this part right here on the bottom would solve a lot of our issue. So if we were to, for example, add this block here, we would probably be okay to do that too. So we could do something like that and that. And we could turn around and do the same thing over here. Just like that. Well, we could go further. We know we can go further. Let's plop it down right there. And right there. Okay. Let's see, are we down to 2.5 hours? Oh, so close, 4 minutes. We saved 4 minutes. But I will say this also, we've saved more than 4 minutes because we're saving the amount of time we have to cut this off. So we've just made a smaller part. So check it out. So we may be interested in moving. Oh no, wait, yeah, because now we're down to this tiny little thing here. And I just want to point out, you can see the structure, but remember I showed you those spaces, those gaps. Look here, look at the blue. Look at the blue part of the edge. I'm gonna come back. Check this out. Do you see the detail there and the detail here? If we get into this, let me change my screen here so I can see what I'm showing you. If you see this here, this gap right here, this space, these spots right here, that's a little like X-type pattern. And I just want to point that out because that's what makes it a little bit easier to break off. It's not completely connected. So if you see that blue, let me zoom really close into that blue right there. You can see that blue right there on the upper left is that kind of like X-shaped pattern right there. And it's what's keeping this part, this tower separate from the actual print. And when we snap this off, some of that's going to be stuck on there. We might have to sand some of it. We might have to use this razor knife here and scrape some of it, or cut some of it. Like you can see all this stuff here is going to be more stuff to cut and clean and process. So while we only saved 4 minutes on that, we're going to save time with having to snap all of this off and having to cut, clean, sand, whatever. So the 4 minutes on the print time is not exactly accurate because there's, like I mentioned earlier, some post-processing that has to happen. And this also means that there's some things we could do instead of printing with a structure altogether, instead of doing all of this with a structure, there is a possibility that we could build a support structure on this print. We could go back into, we use Tinkercad for this, and we use Tinkercad because it's free. So I'm going to come back to me for a minute. I'm going to explain this for a minute. So we use Tinkercad because it's free and anybody can get to it at tinkercad.com. They are not our sponsor, that we are not affiliated with them. It's just a free platform. It's easy to use, and I prefer to share 3D printing design software from start to end on software that's easily accessible. There's no barriers to get to. People don't need to be rich to buy Fusion 360 or SolidWorks or any of the things that I use as an engineer. But Tinkercad is free, and we could go back into Tinkercad and we could actually add little towers ourselves to our print if we didn't want to go the route of creating this support structure or cutting away this support structure. Maybe we really want something tiny and specific and to one point on there. So it's possible we would just add a support structure of our own. And I don't have the software set up today. I don't have Tinkercad open. I don't have that browser ready to share in a window because I'm sharing Cura. So that part is not going to happen, and that's where it can get really intricate and really detailed, and that type of building in Tinkercad is harder than in Fusion 360 if you know what you're doing. If you mastered the learning curve of wow, there's a million buttons. What do I do with them all? But anyway, I just wanted to point that out. I wanted to show what happened, and now that I'm just gonna grab these. I'm gonna come back. Dun, dun, dun. Check it out. So we've got these face masks, and this is what I really want to just wrap up with. We've got these really super cool face masks. Look, check them out. Check them out. I love it. This one is actually making me think that we could design the face mask like a gladiator shield or something that looks just like this. I'm psyched about this. I might put it in Fusion 360 and make some modifications to it so that this support structure turns into more of the kind of like gladiator face shield. But I dig this. Look at this. This is going to go on a robot, and it's going to look awesome. It's going to look badass, and that is super cool. I was super tempted, even with the struggles with the prints today. I was super tempted to break a robot out so that we could put it on a robot. But as far as features and things we designed in Tinkercad, we knew that we would have trouble attaching this to the robot. So we created the lid here, the top here, the cover, the hat, flat so that we could print it. And we added a little lip on the bottom so that it would hook on just like that and stay on the robot. And it design-wise, the design looks good. It looks like it works. And it's now more just a challenge to get it printed and to get it processed. And this will take a while. This probably, I'll be honest, this will probably take me 20 minutes, half hour. I use a variety of tools. I use everything from, you've seen the tools I use. This is a, there's no real technical name for this. I call it a pokey thing. I stab and poke stuff with it, like holes in circuit boards and stuff. Yeah, I do all kinds of stuff with it. And I've got a utility knife, a hobby knife. It's an X-Acto, and something else I use for some of these small prints when I need to file stuff and clean the little like blobs and lumps off of the print. One time my daughter came to visit and she left fingernail files, and well, I never threw them away, and one day I stumbled on them and I said, oh my gosh, I bet I could use that to clean off my stuff for my 3D printer. Works great. I love it. Now I just buy them. People look at me and think, well, he's doing something with his fingernails, and they don't know. I'm not doing anything with my fingernails. I'm filing off little plastic pieces from 3D printer stuff. That's it. That's all I got. I'm gonna turn off the shady lights here that make my shade around me even worse. I'm gonna relax and try not to, look at current events. Maybe just for a little bit. Maybe I'll go play some video games. I don't know. I'll probably do some work. I'll probably finish this. But anyway, take care of yourselves. Good night.